Hello, everyone, and welcome to this Mobile World Live webinar. I'm Kavit Majithia, Managing News Editor of Mobile World Live, and I'm delighted to be your moderator for today's event. Over the next hour or so, we are going to be exploring the topic of achieving zero-touch operations and automating cloud-native deployments in telco networks. Now, the latest advancements in automation are transforming cloud-native deployments in telco. And in this webinar, we will delve into cutting-edge approach of managing every aspect of deployment, spanning infrastructure, cloud-native network functions, configurations, and data as a code. The session will aim to provide a number of key learning points, including mastering cloud-native automation, achieving zero-touch operations, streamlining deployment phases, leveraging real-world use cases, and driving operational excellence. Delighted to say I'm joined by 4 speakers today, 3 of which are from Titanium platform. Firstly, we have the company's CTO, Patrick Rokaita. Hi, Patrick.
Hi.
Great to have you, Patrick. Secondly, we have Titanium CEO, Bruno Lacoste. Hi, Bruno.
Hey, everyone.
And thirdly, we have Jesus Andres, who is the product manager of 5G Core. Hi, Jesus.
Hi everyone.
And finally, we have Tim Hatt, head of research and consulting at GSMA Intelligence. Hey, Tim.
Hey, Kavit. Good to be here.
Great to have you. So our webinar, we split up into a few different parts. We'll begin with Tim, who will give us an overview of the wider market before a presentation from our experts at Titanium. We'll then move on to a panel discussion before concluding with a short audience Q&A. To submit a question, please fill out the box on your screens and we will do our best to answer them. And with that, I'll pass over to Tim to give us a lay of the land.
Great. Thank you very much, Kevin. And as you said, it's what I wanted to do here was set some context for what we're seeing in the telecom sector and their supply chain and wider ecosystem around not only the factors sort of driving the increase in automation, but now with AI becoming a bigger part of the thinking, how we think about that in the future. How that looks from an opportunity perspective and also about the barriers. So I'll talk for about 10 minutes and then we can transition to the next segment. So it's always useful, I think, to remind everyone where we sit within the network investment cycle. Right now, in the 5G era, which started in 2019, we are sort of midway through the 5G network investment cycle. 6G will launch later in the decade, around 2028. But you have this picture where we actually have the most rapid adoption path of any prior generation of mobility. And what that means is that there's a level of network investment that's being devoted to this, but also that caters for the increasing complexity we're seeing as more and more operators move to cloud native architectures, 5G standalone coming in, and the need to have agility and flexibility to manage that. I think from a telco perspective, the other sort of important context slide is that whilst we've seen the infrastructure investment in the networks grow, you still have this long running growth challenge. And what this chart is sort of, if you could distill it down to a word, it's that investment has continued to grow for the last sort of 25 years since 3G was launched, but really not since 10 or 15 years ago have we seen substantial incremental growth per year. And that's due to a number of factors that I think are fairly well established. The point I make around the future is that operators are continuing to look at ways both to drive new revenues off the networks that they have, particularly in the enterprise segment. And secondly, that cost streamlining is always a priority in this environment. And automation really, helps both of those factors. So I just wanted to put that out there as important context. This is some data from a survey we ran of operators on automation. And I wanted to make this point because it's useful to ask the question, what are we doing? First principles, what are we actually doing with automation? And really a lot of it comes down to making the complex simple and being able to manage quite disparate network environments in a cost-effective and resource-effective way. If you ask operators why they plan to introduce automation across their network footprint, you get a whole bunch of different responses, as we show here. Energy efficiency comes into it, managing complexity I've already talked about. But actually, top of the list there is really having to cater to this complexity and being able to simplify it. So there are a whole bunch of reasons as to why operators and others are moving to a more automated environment, but these are only going to grow as more of the world comes on to a cloud native environment, as 5G penetration, rises up. The flip side of that is to understand the cost implications of having a more efficient network operating environment. Now, this is a sort of heat map view that we've worked up around just taking one part of the operator cost structure, in OpEx, and looking at the various sort of line items that go into that. The point I would make is not to get too bogged down in the individual numbers, but it's that if you reduce costs by a given level, 10, 15, 20%, as shown here across those top columns, you can actually translate into quite a savings in network OpEx overall. So if you look at that service optimization and maintenance, again, a key line that automation would target, reducing that by 15% translates to a 1% reduction in OpEx. Now, again, that may not sound huge, but in the context of multi-billion-dollar cost structures and businesses, that actually has a significant flow-through effect in terms of profitability. So, of course, these are notional numbers. These aren't scientific predictions, but they are based on what we know the cost structure to be, and automation can really help streamline that. So that's a big part of the rationale as we look at it. Now, it's also interesting to understand where the industry sits in terms of their deployment status. We run a network transformation survey every year, which covers operators across the world. And as part of that, we ask them where their deployment status is across a range of network categories, and also what they intend to do in the future. Now, I've put automation on this chart with some other categories that operators also invest in, APIs, private networks, et cetera. And you can see there's sort of 2 points. One, you have a sort of minority, sort of 25, 30% that have it at scale across their network right now. But actually, the bigger point to make is that the bars above it, the planning and testing stages, actually show future intent. And so you can actually make the point, all operators are intending to automate their networks. So this notion of a zero touch isn't fiction, it's real. The question is how you get there. And again, I come back to the point of needing to implement automation tools in line with network complexity so that it makes the life of an operator easier to manage that network transformation. So I think it's important to say we're still mid-cycle in where the automation journey goes rather than at a late stage. There's still a lot of headroom to move into. Now, any discussion around sort of the future of automation has to understand, well, if we're talking about a certain share of the industry that intend to deploy it and those who already have, for those who haven't, or even those who intend to, what are the challenges they see that get in the way of this or that slow it down? And so again, I wanted to bring in some of the sentiment findings from that same network transformation survey and show what operators report that, in their opinion, are the barriers to automation at different layers of the network. So the RAN, the radio network, the data centers that power their core, and then the transport layer. And you kind of get these results. So you can see in the RAN, there's a lack of trust in the tools that they see on offer. That's seen as the number one challenge. Internal expertise, owning the problem in the core, uncertain internal ownership on the transport layer. And the penny kind of drops here because you get to a point where you say, well, actually, the barriers aren't really to do with technology. That picture is in place, and the innovation, and we'll see this from our partners at Titanium here, has made great strides. It's actually more in the cultures and systems needed to drive this through the organization when you are in complex network transformations. And so I think there's an implication for automation specialists and operators to work very closely on long-term roadmaps as to how the automation tools enhance network efficiency from a security perspective, from an energy perspective, and from a QoS perspective, quality of service, so that the automation tools work for the long term and they're sustainable. And the case study proof points we've had from operators who have gotten over these challenges before are very positive. So we see this as moving ahead for sure. I'm sure our other speakers will reference the growth in cloud native, and as workloads continue to migrate towards that direction. I think this is really a case of just understanding what residual challenges do remain, and then tackling those through collaboration. So I'm going to stop there. This is a bit about us, but you can get in touch anytime with GSMA Intelligence because we do cover automation in some detail. But with that, Kavit, I will hand back to you to take us into the next segment of today's session. Thanks.
Great. Thank you, Tim. That sets the scene nicely for you, Patrick. So I'll hand over to you.
Yeah, thank you, Kavit and Tim. Let me go into the presentation mode. Here we go. So good morning, good afternoon. Welcome, everyone. My name is Patrick Rokita, and I'm CTO here at Titanium Platform. Titanium is a leader in signaling, routing, subscriber data management, and security software and services. And in today's session, I'm pleased to showcase how Titanium is delivering real-world solutions that help our customers, who are the mobile network operators and IP interconnect service providers, enhance operational efficiency. So telecom products have significantly evolved, transitioning from physical to virtualized network functions that provide reliable telephony, messaging, and data services. And today, cloud-native network functions are driving the next wave of innovation, enabling more flexible, scalable networks that enhance both operational efficiency and overall user experience. And the next frontier is the AI-native functions, which elevate this evolution by intelligently optimizing resource allocation, predicting system failures or bottlenecks, enabling faster threat detection and responses, and seamlessly adapting the user needs in real time. And this technological progression sets the stage for zero-touch operations where cloud-native network functions are critical enablers. As you know, the telecom industry is rapidly evolving, and staying ahead requires embracing the latest advancements in cloud-native technologies, end-to-end automation, rules, and AI-driven autonomy, and network and services exposure via APIs. So our focus today is on how these technologies are enabling zero-touch operations, making deployments more scalable, automated, seamlessly integrated, and cost-efficient. Let's start with the deployment automation. Deployment automation delivers on-demand zero-touch provisioning of even complex systems, allowing us to achieve endless repeatability and consistency without manual intervention. And this approach not only reduces the risk of human error, but also leverages public cloud infrastructure to provide critical cost control through a pay-as-you-use model, ensuring optimal resource utilization. And notably, everything demonstrating during this session runs entirely on a public cloud environment, which is ideal for temporary and on-demand activities such as product demos, proof of concepts, trainings, root cause analysis, and various types of testing, including functional conformance and performance testing, and for validating the quality of experience. So By leveraging automation and integration, we empower our customers to achieve new levels of operational excellence. And throughout this demo, featuring the Titanium Cloud Native Platform and the Titanium ENUM-DNS and the 5G Security Edge Protection Proxy Cloud Native applications, I will guide you through two key sections that highlight our approach. The first section will be about automated testing, utilizing ENUM-DNS as application under test. And the second section will be about autonomous operations on the 5G Security Edge Protection Proxy. So let's shift our focus to the first showcase featuring the automated testing of the Titanium's ENUM-DNS application. As we increasingly rely on cloud solutions, reliable service discovery becomes essential. And DNS domain name system, plays a crucial role in translating fully qualified domain names, like titaniumplatform.com, into IP addresses, ensuring continuous services accessibility without the need to provision explicit IP addresses, which is common in legacy networks. And then with the rise of 4G and 5G telephony, particularly voice over LTE and voice over new radio, leveraging the IMS core, the IP multimedia subsystem, the ENUM service is essential. The ENUM service facilitates efficient breakout decisions and enables number portability, allowing calls to be routed transit-free. And this enhances the user experience by reducing latency and optimizing network resources and, of course, service usage costs. But the key is that our customers expect more than just an application like ENUM-DNS. They need a complete package that includes a robust test suite capable of validating the deployed application at any time. From Titanium's perspective as a supplier, testing requirements are not just technical checkboxes, but key components of delivering reliable and high-quality products to our customers. And in this part of the demo, I will showcase a portable test suite that utilizes the open platform for network function virtualization, OpenFV, now ANUKET cross-testing framework. This test suite is also critical for building and automating testing pipeline, and we will explore this aspect in more detail later in the demo. For now, let's focus on the test suite components highlighted in blue. Those are the test agents, the metrics collector, and the dashboard application that visualizes the results of the continuous testing process in near real time. For data exchange, the test suite incorporates the cross-testing component represented by the violet box, which generates test logs in an industry standard format, facilitating easy interchangeability of test results. And this easy interchangeability is key because you need to have a handover media between the suppliers, maybe proprietary or specific test suite, and the operator's continuous integration process where the automated testing pipelines are built. The recording we are about to watch showcases a single-click deployment of the entire cloud-native stack, including the Titanium platform, the Titanium ENUM-DNS application, and the test suite. The recording features the operational process on the left side and the target system on the right. And initially, obviously, the operational process is idle, and the target system does not yet exist. So let's observe what happens when we initiate the deployment task. In the initial deployment phase, we see the setup of the cloud-native stack on Amazon Public Cloud, which typically takes about 20 minutes in real time and involves setting up the virtual private cloud with associated networking and security characteristics. In the next step, we deploy the Kubernetes container orchestration framework that is provided as a managed service by Amazon. Next, the automation task will spin up the Kubernetes worker nodes that host our containerized workloads. And finally, we deploy the Bastion host, which provides secure administrative access to the deployment. The second phase involves deploying the essential container and platform services required by the deployed system, the Titanium platform delivering common platform services, and the Titanium ENUM-DNS application that utilizes these services. These are further exposed via load balancers for external provisioning and OEM tasks. This phase takes roughly 15 minutes and includes the global distribution of data necessary for accessing the deployed services through a standard web browser you see on the right. So within 35 minutes, the system is fully deployed and accessible, ready to execute a desired task, which in this case is the functional test of the ENUM-DNS application. You see the test suite execution visualized on the right and the cross-testing task on the left. The cross-testing task creates a machine-readable snapshot of the application health at a given point in time. We triggered it explicitly, creating the event to this cross-testing box. The dashboard on the right, however, is particularly valuable as it visualizes temporary glitches that cause tests to fail. And it is typically connected to an alert system, minimizing the need for continuous monitoring. To the results, you see that both processes indicate 6 failing test cases. Based on the severity of the failures, we can determine that the deployment is not suitable for use. And so before we address the automated testing pipelines, let's fix the failed test cases and rerun the test. Here we go. To consistently capture the application health, an automating testing pipeline is required to verify at regular intervals that the application operates correctly. Automated testing, integral to continuous integration process, leverages tools such as Jenkins or GitLab. And with a provided test suite, the testing pipeline can automatically capture snapshot of the application's health from the test log files created by the cross-testing component and store them in a database or object storage. As long as all tests pass, the service level agreements remain valid, guaranteeing consistent performance and reliability of the application. The continuous integration framework can be deployed using the same automation process as in the previous example. Once the system is up and running, the testing pipeline activates, runs the test, and publishes the collected test report on the configured storage system, such as Amazon S3 object storage in our example. And similarly, you or your customer can integrate other tests, such as the CNTI conformance tests of the cloud-native applications or Kubernetes platform into the automated testing pipeline. So with everything now up and running, we have seen firsthand how quickly and seamlessly the entire deployment and functional testing come together, showcasing the efficiency and power of this automated process. Time to move on. So we have completed the deployment validation process utilizing the cross-testing framework, and we'll now shift our focus to the Titanium's 5G Security Edge Protection Proxy. And more specifically, I will demonstrate how SEPP's autonomous capabilities facilitate a seamless zero-touch operational experience, highlighting the impressive efficiency that sets this technology apart. The 5G Security Edge Protection Proxy is deployed at the boundary of the mobile core network, protecting it from fraudulent access and message content spoofing. SEPP establishes secure connections between the local core network and various remote core networks, applying strict security policies to every message exchange between the roaming user's equipment and the user's home network. The number of interconnects varies based on each remote network topology. In this case, there are 3 interconnects between the local network on the left and the remote core network on the right. The challenge lies in setting up and managing these interconnects efficiently. So traditionally, telecoms manage interconnects with manual oversight, controlling every detail of the connection. And I will illustrate this process by establishing the 3 interconnects shown in the previous network diagram. Initially, no traffic flows between the local and the remote network. But once the first interconnect is configured, traffic starts flowing along the established path. You can see the number and the status of the interconnects in the upper part of the dashboard and the roaming traffic flow and distribution in the lower part. Adding a second interconnect distributes the traffic evenly between both connections. You can adjust that, but that's how it's set up right now in this demo. And then finally, with the setup of the third interconnect, we can finalize the desired topology with balanced traffic distribution. And of course, this process can be also reversed by removing interconnects as needed. You can see it as the demo advances. In the meanwhile, let me make the key message here. While the manual approach seems straightforward, it quickly becomes unmanageable when dealing with numerous remote networks, each requiring multiple individually managed interconnects. Any change in interconnect topology necessitates the exchange of routing information and reconfiguration of both the local and the remote SEPPs, which is a labor-intensive process that large IP interconnect service providers often reject due to the associated effort. And this brings us to the alternative, automated SEPP discovery. And by the way, if you are not a fan of using the command line for managing changes of your deployed system, there is a more convenient approach by using tools that serve as a single source of truth and provide source code management. Every aspect of your deployment can be captured and managed as code and seamlessly applied to the system through specialized continuous deployment frameworks. Examples include Argo and Flux. But for now, let's keep the focus on the automated SEPP discovery. With automated SEPP discovery, the local SEPP is configured with a well-known identity representing all SEPP instances of the remote network. And that's it. Yeah. This setup simply enables the remote network operator to manage the number of interconnects and traffic distribution across them at any given time. You have no work with that. Anything happens remotely. So in the demonstration, you can see the immediate discovery of 3 SEPP instances in the remote network, with traffic flowing according to the distribution schema. And again, the distribution schema is specified in the discovery results, not locally. So with that, the schema can adjust dynamically over time without local administrator intervention. The local SEPP's primary task is to monitor the health of the established interconnects. And if a planned or unplanned outage occurs, the traffic is automatically rerouted by the local SEPP over the remaining paths until the affected interconnect is restored. You now see the detection of a failed interconnect by failing heartbeat that is run individually, and we wait till the affected interconnect is restored. Equally, the remote network administrator can stop advertising the problematic SEPP and redistribute the traffic between the remaining 2 SEPP instances, which we'll see in the final phase of this demo. So SEPP discovery and SEPP heartbeat enhance efficiency by minimizing manual intervention, enabling autonomous dynamic traffic management. And this automated approach scales seamlessly across hundreds of remote networks and interconnects, ensuring high-quality performance and an enhanced operational experience, even in complex network environments. We have now reached the end of the demo, and before handing over to Kevin, I'd like to emphasize 5 key takeaways. First, automation boosts efficiency and consistency across the board. Second, automation fosters win-win scenarios for all stakeholders, including suppliers, mobile network operators, IP interconnect service providers, and end users. Third, transitioning to automation requires a well-thought-out strategy, whether phased, tiered, or hybrid. Then fourth, security and compliance must advance in tandem with automation to benefit everyone. And fifth, with automation and autonomous operations, humans' roles are shifting, but they are not disappearing. Thank you all for watching.
Thank you very much, Patrick. That was really insightful, and it brings us nicely onto our panel discussion today. I wanted to start with a question that sort of sets a strategic tone, and it kind of looks at the industry-wide impact of automation. I wanted to start with you, Bruno, if possible. Why is achieving zero-touch operations in telco networks critical to the industry's future? How does automation drive this transformation?
Yeah, thanks, Kevin. I think it's fair to start with to look at how communications are critical to our society today, and then understand how it makes automation critical within our industry. When you look at where we are right now, communications is everywhere. You have every device, everything is intelligence. You have Internet of Things. It's all over the places. You can control heating system, alarms. You can date online. You can share content online. You can shop online. Everything is communication based, but you can also, other industries are leveraging communications. Nuclear plant are maintained and managed through communication, secure communication networks and devices. It's become a military tool, a weapon So this is how critical the communication industry is, the telco industry is now. And what it does to us, to all of us, service providers, operators, suppliers, it does raise the need for constant change and evolution. We have to deal with a massive pace or a massive load of changes all the time. It's all about enhancing, updating, repairing. It's all about enriching our solutions or services offered to our end customers, the experience of our end customers. So this constant need for change and this pace of change is no more human sustainable. This is just no more doable. And now we must have automation. This is clearly a must have. There's no more waiting for us, especially when you look at the slides presented by Tim on how the industry is trying to grow their revenue, trying to find a sustainable business model, and you look at the investment model versus the growth in revenue for the different players, you can see that it's also vital from a business standpoint. There is no question about it. So for me, automation is not even like a driver. It's a survival. It's a must-have.
No, it makes sense. And we hear that constantly at industry events, how important the industry is now. Patrick, back to you. What are some of the key challenges telcos face when transitioning to zero-touch operations, and how can they be overcome?
Yeah, so I have an opinion on that, and we also saw some key challenges in Tim's presentation, which was great. So I believe that one challenge is understanding the task to be automated. That is simply vital and requires the integration of expertise across different teams, and that's the challenge. No? And it can be overcome, by improving cross-functional collaboration, or maybe you define a new ownership role within the organization. It's also essential to cover the entire deployment lifecycle involving maintenance tasks such as upgrades and rollbacks, not just the initial deployment phase. We always see demoing the initial deployment, but the real complexity comes with how you master the so-called day-to-day operations. And this definitely requires comprehensive planning, for example, by adopting phased approaches. And finally, ensuring that the system can handle also unexpected scenarios will require managing the trade-off between efficiency and flexibility. And this challenge can be addressed with training and data-driven automation platforms capable of monitoring and addressing complex real-time issues. At the same time, we must be cautious not to, over-rely on automation. We must know its boundaries and have really experts in place if something goes wrong, especially in the initial phases. And by the way, because the question was addressed to telcos, these challenges are not only faced by telcos, also suppliers of telco products do face these challenges.
Yeah, I think that's an important point, because it's really talking about the whole ecosystem, isn't it? Right. Jesus, to bring you in here, how does automation techniques streamline the installation and verification phases, ensuring a seamless functional acceptance process?
Mm-hmm. Products cannot be built as black boxes, right? They need to have a special focus on integration aspects, both related to the CaaS infrastructure and to the automated testing pipelines implemented by network operators as part of their continuous integration process. Acceptance processes must get closer to the new customer expectations. It is no longer possible to have months of validation and testing that are just executed once and considered valid for years, as it happened in the past. Acceptance testing should now be repeatable, either on regular intervals or on demand, and triggered by the CI/CD pipelines. This also means that now the definition of done for acceptance tests is not limited to the application capabilities. It also covers the integration into customer CaaS environment and into existing pipelines for continuous integration and continuous testing. We have seen a clear real-life example of what I just commented in the demo presented by Patrick for the deployment and testing of Titanium's ENUM-DNS solution. And I think this will become more and more relevant and common for CNF deployments embracing automated testing.
And Bruno, anything to add on that one?
Yeah, I mean, Jesus, with this product management background, but also his operational background, you can see the value is it's back to this content's needs for change and adaptation. And we have to have tools that can run all the time. They can adapt. They can be enriched with new test scenarios, new security requirements, maybe also new standards, new needs from the market and GSMA and TIP. They're trying to also feed this system with constant improvements in the standardization world. So acceptance criteria will be dynamic. And again, if you think you can cope with it manually or do it the old way, the legacy way we used to do it in the telco industry, I think it's clear, it's obvious that it won't fly, it won't work for us. It's not sustainable anymore.
And just staying with you, Bruno, just to get a bit of a feel for the business case for automation, what sort of impact does full automation have on reducing operational costs, improving service quality, and enhancing the efficiency in telco networks?
Yeah, it's the broad question, and it's the key question for many of us. It's also down to how we make we make our business sustainable and we make our business model viable in the long term. This is, I look at that as many different sources of efficiencies. It's not just, for instance, labor or cost reduction. Everybody thinks labor when we think cost reduction, but it's a lot more than that. Think about time to market. With automation today and with those improvements, we will reduce this time to market. We will introduce this new technology. Again, you've seen team slides and the adoptions of the 5G technology, and the speed of adoption is much faster than before. This is the first benefits of automation you have there. And now you can roll out this new technology and the benefits for the end users of the other industries like the healthcare or maybe manufacturing industries. They can also take advantage of those benefits earlier. Time to market is key. For me, I have a very strong background in operations and maintenance. For me, it's also a lot about business continuity. We lose money, time, and energy when we have outages, when we have services downtime. We lose customer satisfaction, employee satisfaction if we make people work at nights or weekends or holidays. So there's a lot of benefits, a lot of savings there, cost, but also, again, experience for the end users that will have a more reliable, a more robust, and a more sustainable quality of service. I'm going to reuse the word sustainable again. Resources, power, it's critical now the way we manage those resources. We know they are not infinite. We know we need to pay a lot more attention to power consumption, footprint, and so on. But we also have to really take advantage of the technology for that. So this dynamic resource allocation, for instance, this program is really critical for the industry. And without automation, this doesn't exist. We need automation, and this is where the saving will come from. We'll save energy, we'll save money, we'll save our power and our resources. So those are just examples. If I can echo what Patrick said a bit earlier, it's also on all of us to do homework and say, where are my challenges, my pain points? Where are the costs in my business model today? So if I talk about our business and I look at where we spend time and I would like to have a lot more automation, clearly the quality testing, the quality assurance is definitely a focus area for us. Because the earlier we identify problems and we fix them, the best it is for us. If today I have to fix a problem that's only seen when we go live and we roll out software in the field with the end customers together with us on the maintenance window, this is extremely costly to everybody. We have to roll back, we have to reproduce, identify the problem, fix it, deliver a new piece of software, roll out, test again, and so on. We want to avoid that as much as possible. That's what automation does to us in the testing world. That's why also Patrick's demo is a good illustration of where we spend a lot of time and energy these days.
That makes sense. And Bruno, anything to add on the use case?
I guess you for Jesus maybe.
Sorry, Jesus. Yes, Jesus.
Yeah. Well, no, I mean, I think probably I would just highlight when it came to that topic about the operation aspect. I think it's key to identify that this is just identifying a new skill set that is being required, a new approach for how to manage all these processes that are really a good opportunity within telcos for embracing automation opportunities.
And Bruno, you spoke there about the labor sort of impact. I want to open this up to the panel with stuff like zero touch environments. The role of human oversight does get put into focus. What would be the place of humans in these environments? Would you say, Tim? Do you want to kick off with that one?
Yeah, sure, and I think that's a larger point that is really important to bear in mind when you're talking about an AI kind of paradigm that we're moving into. I think first of all, at the core, people have to understand what the technology is doing and is capable of. Nobody wants to install software that sounds good, but they don't actually know what it does, and so there has to be a clear understanding of the functionalities and what the problems that are solving is. I think secondly, a lot of the operators we talk to want to understand what if scenarios. So when something goes wrong, how do you mitigate that? Almost getting ahead of the curve to put provisions in place before problems happen. And then third, I think you need to have human oversight around the future strategy. You can't devolve that to a computer. You can't sort of, do anything other than be directly involved in that. And that gets to the core of how you want to look at automation as a key enabler of your network strategy from a technology perspective and from a cost perspective. And that means how much are we going to invest? What are we judging as the success measures for that? And how do we monitor it over time? So I think all of those come into play, and if you get all those three right, you'll be heading in a good direction.
Anyone want to chip in with the Titanium point of view here?
Yeah, I made the statement in the 5 key takeaways that the role of humans will shift and it will not disappear. Yeah, and I believe it's really important to distinguish between the role of humans and talking about individuals. Yeah, so when talking about the role of humans, it will shift, it will not disappear. So it shifts from manual operations to strategic oversight, as Tim mentioned, and the people will ensure that the system operates within desired parameters. So they will no longer perform repetitive tasks. Yeah, they will rather supervise automated processes and autonomous system focusing on the cloud architecture, broader system health, compliance, policy management. And as Tim mentioned, human intervention will be further necessary in exceptional situations or when the automation encounters an unforeseen challenge. And here for the individuals, continuous upskilling is essential to stay relevant. Let me say it this way. But the good news is that there will be new roles. And like Tim said, example includes the AI ML specialist crucial for developing systems that enable predictive maintenance and real-time decision-making. So there is a chance for each of one. And when we abstract it to the role of humans, it will not disappear. It will shift.
Makes sense. And Patrick, staying with you, just want to get a bit more of an insight into the technical benefits of using cloud-native infrastructure and architecture. What are the key benefits of cloud-native container-based deployments compared to traditional systems in the telco space?
Great questions. 4 or 5 years after the introduction of cloud-native technology. So, the cloud-native technology is defined, is by definition defined for 5G core and is now making it into Open RAN. And when talking generally about the benefits of cloud-native technology, so cloud-native container-based deployments and only in conjunction with container orchestration platforms like Kubernetes, they simply offer greater scalability, flexibility, and resilience compared to traditional systems. The containers are we run the business logic in containers, which are lightweight pieces of software when you compare them to physical or virtual machines. And therefore, they enable more efficient resource management and rapid deployment of new services, for example, by integrating open source community projects. And one another important aspect that comes with cloud native is API and like service and network exposure. So utilizing these APIs, exposing the underlying network or network functions, developer teams can easily create value-added services, allowing telcos to quickly respond to market demands and operational changes. It's not all up to the supplier and to the capability of the supplier's product. By exposing network and services, any external developer team can bring value added. So generally, in a nutshell, things that did not work well in virtualized system are now natively supported by container orchestration frameworks like Kubernetes and cloud native deployments. I know it myself. I spent months and months on doing single-click automation of a virtualized system, and now seeing how easy and reliable it is with cloud-native network function. That really makes the difference.
And Bruno, any thoughts on the key benefits of a cloud-native deployment?
I guess it's hard to add to what Patrick just said. I think I want to go back to those benefits. They have to be thought through. They have to be designed. They have to be discussed and strategized. So again, I can talk about the business we're in, and on the software side, what are the benefits for us in cloud native technology and automation together. But if I talk to one of our customers or maybe one of our partner, those benefits can be different, and they will maybe weigh in and seek different outcome than we are. Now, there are a lot of common themes. I mean, Patrick covered on the testing side and the automation, but yeah.
I can add, but the risk is that with a CTO view, everything is like technology. But imagine a monolithic system, whether it's physical or virtualized. If you do anything to the monolithic system, you take down a lot of functionality at the same time. Yeah. So you need to run cluster-based function that defines master responsibility for the operations, so that you can take one node down. With microservices, you basically create a service impact or small service degradation to a small piece of software. Yeah, you never impact the entire system. And again, I want to amplify the benefit of the container orchestration frameworks like Kubernetes. They continuously monitor the running containers and for readiness and liveness. And in case the container does not respond to liveness probe, it will automatically restart it, self-healed from the orchestration framework. If it doesn't respond to readiness probe, it will not participate in the processing of the traffic that is coming to the system. It will be excluded from processing the traffic. So there are differences, and we probably could talk hours and hours about them. I wanted to highlight these two: monolith versus a small piece of software, and then the resiliency and self-healing capabilities delivered by these readiness and liveness probes.
Just looking at the different types of cloud and the advantages over one over the other, how does integrating public cloud services streamline operational efficiency compared to on-premise and private cloud solutions?
So, as of today, public clouds are ideally suited for ephemeral and ad hoc activities like product demos. What we have seen run entirely on public cloud. So you can run demos, proof of concepts, training, root cause analysis. I mentioned various types of testing. We saw the functional testing. And nice thing is that public clouds come with built-in automation tools and APIs, and they are enhancing the deployment speed and flexibility while operating on a pay-as-you-go model that controls cost and avoids over-provisioning, making the operations more efficient. And especially for us as telco suppliers, we usually deliver cloud-native network functions and the associated, we call it Helm charts, to deploy them. And if we would deal with infrastructure setup all the time locally, we would basically shift our focus to something that is not our core business. Yeah. So especially for us, the public cloud services streamline the efficiency by offering scalable on-demand resources with global reach. Yeah. And they reduce the burden on our internal teams by managing hardware and software infrastructure, allowing us to focus on our core business. And looking ahead, as the telecom industry gains increasing confidence in the security and reliability of public cloud environments, we may see a shift towards more production-level deployments utilizing these platforms. For example, in blue-green deployments, we can start with putting less critical operations or services on public cloud, or use public cloud as a backup system in case the on-prem deployment fails for any reason.
Okay, we've got about 10 minutes left, so I just wanted to get a few real-world use cases and success stories into this sort of story. Jesus, if we start with you, what practical lessons have you learned from demonstrations using Titanium solutions, and how can other telcos replicate this success?
Mm-hmm. Well, one key lesson learned is that telcos have widely understood that automation is the only way to go. There was a time where telcos could be reluctant to incorporate the automation into deployment and acceptance phases, with the concern of losing control on these business critical activities. We see from our customer interactions that this is no longer the case, and automation is identified as a must going forward. We have also learned that getting there requires going through a learning curve. Telcos should benefit from friendly trials like the ones we have conducted with several customers to help them identify and elaborate their automation strategy, processes, tools, and resources allocation. More on the technical side, we see that DNS is becoming more and more important for the telco industry within the core network. As an example, Patrick was mentioning in the scope of automation requirements, the usage of fully qualified domain names is preferred instead of explicit IP addresses. And for 5G core use cases like the automated discovery of roaming partner SEPPs that Patrick was showing, DNS is also introduced to provide automation. Finally, one key lesson learned from these demonstrations is that mastering the processes defined for cloud-native products and solutions is at least equally important as delivering the required functionality. Adding missing functionality could even be less problematic than lacking support of a process needed to deploy and operate the product or solution in an economically efficient way.
And just staying with you, Jesus, how do automation techniques address the flexibility that manual management provides while still achieving the efficiency gains of automation?
Well, flexibility is typically understood as the configurability applied by a human operating the solution. And flexibility is not moving away with automation, right? What changes is the way to manage those configuration changes. Network operators will need to design their end-to-end lifecycle management for their solutions through automation processes. The flexibility on the operation will need to be reproduced into the automation chain, while the execution of the changes into the system should be left to the automation tools. They two configuration changes are released with a particular release number for the proper change control through Git as a single source of truth, but manual interventions will still be possible. Tools allow for temporary changes that should link to well-defined reconciliation processes. In any case, these type of changes related to disaster recovery scenarios can also be prepared and executed through the automation tools.
Just a quick word on a topic we're all familiar with, security. What security risks are associated with automating SEPP and PLMN interconnects, and how are these mitigated in a cloud-native environment? Patrick, if you want to start with that one.
Yeah, good question. So let's be honest, automating SEPP and PLMN interconnects bring some inherent security risks. But I believe that even in highly automated environment, the risk of breaches can be minimized through regular security audits. And we do also hop-by-hop encryption, DNSSEC. We have automated lifecycle management for certificates and trust management involving the exchange of root CA certificates. And our customers continuously monitor network traffic where every routed message is scrutinized directly on the SEPP. And as we go forward, rules and AI-driven analytics and closed loops will allow for real-time anomaly detection, which is essentially addressing potential threats before they cause significant damage. So, yeah, I mean, I also said in the key takeaways to refer that again and again, that the security must evolve in tandem with automation, and we pay extreme attention to that. Yeah. And let's be honest, I mean, you need to build security, even whether you automate or not, this is not mutually exclusive.
Jesus, any words on the security aspect?
Well, yeah, I mean, I would say one risk mitigation that comes already from the fact that 5G S8 interconnects are already bringing signaling encryption, which was missing on legacy technologies like SS7 and diameter. Also, the automation of PLMN interconnects at SEPP is achieved by incorporating DNS, and DNS is security threats are widely known by the industry since it has been used for decades. At the end, security requires covering the end-to-end scenario, so securing every single step of the chain. In this specific PLMN interconnected scenario that involves the cooperation between all mobile network operators, it is also key to build the right processes through industry standardization.
Okay, and just to wrap up the panel session here, just wanted to get a perspective from Bruno, Patrick, and Jesus on this one, and it's about AI and ML. Looking ahead, how do you foresee AI and machine learning enhancing zero-touch operations in telco networks? Bruno, kick off with you.
Yeah, it's really something like close to my heart, but also close to recent discussions we have had with our partners and customers. So, a lot of us, almost all of us, everyone I've talked to, we're anonymous. It's the world of operations and maintenance is the place to start with this technology. AI and ML are new tools, but they can bring so much value in operations and maintenance. Think about some of the use cases. So if you have an intelligent assistant, a chatbot, or anything like that, will help you troubleshoot or repair a problem, a piece of software that's faulty, not behaving as you wish. Now you win a lot of time. So those technology wouldn't enable that. Think about maybe the self-healing scenarios that Patrick was discussing, or the dynamic resources allocation. Now, when you have this intelligence, this pattern detection, the data aggregation powered by AI technologies, you can aggregate all those data and take actions in real time or pseudo real time. There's a lot of savings also and downtime savings there. For maybe another one is really going back to sustainability and power or resource consumption. This dynamic resource allocation is big in 5G radio, but it's also big in the 5G core now. We can be smart in the way we use software or footprint and resources for software allocations. Patrick showed how we leverage a Titanium cloud infrastructure for temporary needs. And pay as you use, pay as you need, and it's also efficient commercially wise. I mean, this is where this technology is really a huge enabler, and really the tool, the critical tools for efficiencies and cost savings down the road.
Jesus, any thoughts on that one?
Well, I think from more from the product management role and position, thinking about AI on the short term for our product's evolution, I think it is key to identify specific and concrete use cases, as Bruno was mentioning, that could provide a real and tangible benefit. So this is currently part of our research activities. The target, it seems to be on these initial use cases around operations and maintenance improvements. Definitely that seems to be a key area to focus on. And we also think that within the 5G core, elements that play a central role in the signaling networks could be key due to their visibility of the entire network signaling, right? So this is the case for SCP on the national traffic or SEPP when it comes to the international traffic.
And Patrick, I'll give you 20 seconds to give us the final word.
I make it simple and very abstract. I believe that here we are operating in a core network, a 5G core network, and we will learn a lot from the radio access network, where there are challenges, with the resource allocation to serve the symmetrical high download and upload speed to deliver like extended reality, that completely changes the way how resources must be distributed with throughput to many users in the area of the antenna, and that only goes dynamically in real time by applying AI-driven algorithms. So it will make it into the Open RAN or into the RAN, and we will benefit from it in the core, whether it's adjusting configuration based on traffic patterns or predicting system failures or identifying unusual behavior of the network and preemptively addressing threats.
Thank you, Patrick. Well, I think that is a great place to wrap up. Thank you so much to our speakers today and our audience for taking part. If we did not get to answer your question today, someone from the team will get back to you. And if you missed any of the content, it will be shortly available on demand. Thanks again, and we'll see you again next time.